let's see, I've done a lot of open source work over the last few years, part of an organization called TanStack. And I bring that up here just because over the last 3 weeks, I've been working on what we thought would actually be like a very like minor utility library, but now we're actually trying to make it into a whole new like official TanStack library. And you guys are kind of the first to see it. So it's unpublished, but I want to talk through the concepts of it. So yeah, throughout all of our TanStack repos, like, and for those who, I don't know, is anyone here like not familiar with TanStack? Yeah, all right. So TanStack, it's like an open source organization that focuses on making high quality JavaScript libraries, mostly traditionally for React, but now we are framework agnostic. So we try to support like all the major frameworks, React, Vue, Angular, Svelte, Solid, etc. You know, our philosophies are like extreme type safety, very easy to discover APIs, being like very lightweight and very, very focused, and just like being a joy to use and being as compatible with all the rest of your code as possible. I'd say that's kind of like the core philosophy. So there's like a lot of TanStack libraries out there, so I'll actually bring up our TanStack site. So there's like TanStack Start, Router, Query is our most popular one. Table, one that I mostly maintain. You'll see this new one that's popping up in the corner here. This is on a preview URL, so if you go to tanstack.com, this is not actually showing up yet. It's in the draft PR. But this is the library that we're making. So what we did really is that we had like a whole bunch of like queuing or equality checker, bouncing and throttling utilities kind of sprinkled throughout all the code bases. We kept having to like duplicate it. And we thought, well, can we put all this code into its own like repository, just make like a bounce utils like sub package pretty much, so we don't have to repeat all this stuff. I kind of stepped in and said, well, how about we clean it up, give it an official brand, like an actual name, and make a library. So that's, yeah, just over the last 3 weeks, that's what I've kind of been doing. Yeah, so the main focus of this library is all about like rate limiting, throttling, debouncing, and queuing stuff. Does everyone here think they know like what all that means? Or do you think like all those are exactly the same thing, just the same name for like the same thing? Because that's what I used to think. But actually each one of these are slightly different. And so I kind of want to just like show you guys like what all the small differences between those concepts are. So rate limiting. Rate limiting is like a very popular concept, especially on backend development. This library is kind of, well, mostly focused on the front end, at least in the examples I'll be showing. So rate limiting, it's you're just putting a limit on the maximum number of requests in a time window. So an example, 2 requests per 1 second, 20 requests allowed per minute. You know, it could be network requests or just function calls in general. That's the basic idea. I think whenever people think of like throttling or rate limiting, this is like the first thing they think of. So like it's used to prevent abuse, but so actually rate limiting, like out of the other 2 options of throttling and debouncing, it's actually kind of the most naive approach. So it allows like all network requests or all function calls to get through. Then once the rem is leached, you're just like cut off. It blocks everything. So I'm actually going to jump over and give a visualization of that. We'll open this, zoom way in. I'll also like kind of open up the code. All right, so this is like a React component now using our TanStack Pacer library. The kind of idea is like you click this button, we expect our local state to update immediately, but then like maybe this is like state that we're going to be sending to a backend API or represents like you're going to be sending an API call. So like, I'm going slow right now, I'm not hitting the limit. The limit is like 5 every 5 seconds. So like, practically, mathematically, almost the same as 1 every 1 a second. But you'll see, like, once I hit the limit, it's paused for a while, then it like all of a sudden allows 5 in. So it's like really like kind of batched up. This might be a little bit easier to see on our like texting stuff. So our rate limited text like was just frozen for 5 whole seconds as soon as I hit the limit. So yeah, it's rate limiting. It's an approach. Like it's really good. Like if you're just really trying to just block stuff, it's more useful. Like the wrap up backend API, like in a rate limit, and start denying people once they exceed a quota. I want to go to our next concept, which is throttling. So throttling is just like rate limiting, but it's going to ensure that events can be executed at least once per the interval. So it guarantees like more consistent execution regardless of call frequency. The same number, it's going to have like mathematically over a long period of time the same number of executions as rate limiting, but it's going to be just a little bit smoother and evenly paced. So I'm going to open up our throttle example now. All right, so throttling. The settings on here are, I need to actually open it up. We're just going to say, we're going to throttle pretty much like 1, it's an implied 1 here, every 1 second. So mathematically the same. So I start like increasing the count. You'll see once a second, our throttle count is getting updated. If we start typing stuff in at least once a second, we're letting the throttle state actually update. So it's never more than a second behind. In a rate limiter, like it could get way out of date if a limit got exceeded really fast. So that's throttling. It's a little bit, just a little bit smarter of a way to do it. Now I want to go to the bounce example. Or first, I guess we'll introduce the concept. So the bouncing. This is like one where if you ever have used any of this on front end, this is probably the one you've used. It's like really common to attach to a search box. So the bouncing, it delays the execution of a function until after a specified of time has passed since the last time the event was triggered. So usually, this strategy actually is going to result in the least amount of executions, like often like even only 1 execution. So instead of like sending like a regular stream of events in, we're going to say, well, if we're getting a whole ton of events at a time, and we only care about the last one, like on a search box, you actually want to wait until they finish typing whatever they want to type. We're just going to wait until they stop and then send whatever they typed last. And often the bouncing can actually be customized to act a little bit more like throttling if you want. So you can give it like a max wait time. Like you can say like, oh, like it's been 5 seconds since we actually tried to send a request. Just send 1, but then we're just going to go back to the bouncing and waiting until the end. So we'll look at that example now. So I'm going to just like, I'll click once, it updates after a second. If I click a bunch, our debounced count is actually not getting updated at all until I stop, and then it finally like lets that value in. And then here's like our search box. Like it hasn't even like updated at all. We're finished, then it like sends it off. Our debounced search state actually is sent there. I want to actually show some see whether some websites are actually implementing this or not. So like here's like google.com. I've got the network traffic open on the side. If I start typing in on Google, you'll see there's actually, Google doesn't like throttle or debounce at all. So they're just letting all requests through. Google searches must be really cheap. However, if you go over to Twitter, where they're a little bit more strapped for cash right now, so you'll see I'll start like hitting my search, they bounce. So they're only letting like the last request through. I wanted to see Blue Sky, because I know Blue Sky uses TanStack query. So let's see how they do it. It looks like they let all requests in, but as I'm backspacing, Rack query is actually caching and like catches some of the things I've already typed. So I don't know if I do Dylan once and then Dill, then it looks like it did that through. But it's only sending the requests that are unique. Yeah, so that's the bouncing. I didn't have a timer to see how much time I have left, but yeah, so all of those three strategies, so rate limiting, throttling, and debouncing, they're actually like blocking requests. Like you're losing, like they're very useful if you only care about like some of them, you only want some of them to get through. But what if you're doing something where you want to rate limit it, but you don't want to be losing stuff? Like let's say like you have like 10 tasks that need to be done. Like, or hit the API, same API 10 times with 10 unique API calls, but you don't want any of them to get blocked. That's where, we're going to introduce like another concept called queuing, where sometimes like you can call it task pooling or scheduling, or there's a lot of names for that, but in the library that I'm making right now, we're kind of just calling it queues. It's also at version 0. We might rename everything at some point, who knows, but yeah. So queuing, it's like a system where tasks, requests, or data are collected and held in a specific order for processing. So this can be like first in, first out queue, or a stack, last in, first out, or like priority queues where there's some like sorting criteria in the queue where whenever you add something to the queue, you can add it to the beginning or end or wherever it needs to be in the priority. You can have wait times between tasks to slow it down. So let's say like, we're going to make sure everything goes through, but they're going to be 1 second spaced apart or something like that. You can have asynchronous concurrency to speed things up. Let's say like we actually want to run like 5 at a time, or in batches, or pretty much as soon as one finishes, we want to always make sure that at least 5 are running if they can be, for processing like 1,000 things. And some queuing stuff, like you might want to keep track of errors and have retry logic in case some of those fail. I can at least demo one queue thing. Use Keeper. So we'll get a visualization of a queue. This is a very simple example where we have a list of numbers, like 1 to 10. Whenever I add a number, it's just adding something to the end. I will open up the code so we can see the examples too. So what we have here, max size of 25. We have this initial items of that array. We're going to say wait 1 second between processing items. We could get rid of this wait, and it would just be a pretty much synchronous, just process them all as fast as you can. So I can like just keep adding. I'm going to manually just process, and you'll see it's processing the very front of the queue. So first in, first out, 5 minutes. Then I'm going to, so this hook that I have, it has like a built-in tick thing. So I'm going to click start processing. It's processing 1 a second. Add some more, just doing that. So that's kind of the basic idea of the queue. It eventually gets through all of them. I'll click stop those. Or should we, I'll just let it go, see what happens. Nothing's going to happen. Besides the statuses here are going to change. It's still running, I could add more, then it immediately starts processing. Yeah. Just kind of review over these concepts. We don't have to go through all this. But yeah, rate limiting, throttling, debouncing, and queuing all have just slightly different ways of doing some of the same related kind of things. We're making a library for it called TanStack Pacer. Maybe even by this Sunday, we might have this live on the site. Writing some documentation writing more unit tests, trying to fix some more bugs. But yeah, be on the lookout for that. If that kind of interests you. The library is still under design. So like if you've ever been on like wanting to get involved in open source, maybe this is a perfect opportunity. We're trying to bring just like a lot of these similar concepts all together, make it really high quality and actually worth shipping. I do want to share, there's a lot of argument on like what we should even name this. So we're calling it TanStack Pacer. Originally we were just going to call it just the bouncer tills, really boring. Anyone else have any better names? Because technically we still have time to change it again. Tasker. All right. Our original name was going to be TanStack Bouncer, like a bouncer at a club denying entry. I don't know. TanStack Swimmer, so this is actually interesting. So like part of the reason we wanted to actually make this into an official library is that this was actually Tanner Lindsley's first public like GitHub library he ever made, like 8 years ago. So he's the creator of TanStack. So pretty much he called it a task pooler and called it's an NPM library called Swimmer. You can still install it, it's just really old and unmaintained. But we pretty much took this exact concept, put it into this new library. So Swimmer was actually the like OG name of this library. TanStack Pacemaker, which we simplify the pacer. TanStack Tempo maybe. TanStack Cadence, Tasker. I guess maybe you knew something. TanStack Taskmaster. TanStack Wait. Or TanStack Stop. I don't know. Could have been the opposite of TanStack Start, which is our NebraskaJS alternative, funny enough. Yeah, I mean, that's kind of all I have. Yeah, I don't know, any questions? Yeah.
So, I think you mentioned this. Did you say that Ars Technica just had an article about AI bots like swarming websites and absolutely knocking them all offline? Is that something that we can?
Depends.
Protection?
Yeah. I mean, right now this is more like all my demos here were on for like front end interactions and stuff. I feel like those kind of like DDoS attacks and stuff, it's more, you have to like set up more at an infrastructure level, caching level, like actually like filtering out bot traffic, that kind of thing, right? I mean, I know Twitter in the past they themselves have actually had problems where they've like had like infinite front end queries or something that's like where they've DDoSed themselves. Maybe something like this could have prevented that. Yeah. Yeah, all right.